So here's another method that you can actually use to show mean currents. Okay? Not tidal currents, which vary all the time, but something which exists on a time scale of, say, a month, mean currents. And you can show these mean currents in terms of a map of arrows, arrow plot. You can see the flow here in terms of an arrow, where the size of the arrow, including the arrowhead, tells you what the speed is. You can see here is the legend tells you the conversion. Okay. 1 meter per second would be, it's not even shown here, but the strongest currents are sort of here in this area. Let's get the mouse is activated now here. And you get regions where you have very, very weak flows. Okay, so you can identify the patterns of currents. On the other hand, you can also use a method which is called a spaghetti plots to show the structure of the mean curve. In spaghetti plots, again, it's similar to progressive vector diagram. You actually work out what we call the trajectory of a particle, imaginary particle that you throw into the ocean, and you work out the pathway, the trajectory. This is shown here in these diagrams here, so-called spaghetti plot. You also get an idea of where are actually the regions where you have weaker flows, or where are the main pathways of current. What you see here at the bottom is actually the Gulf of Mexico, and this is where the Gulf Stream originates. You can see the Gulf Stream here in this main pathway in this spaghetti. Okay, I also want to show you just a very, very brief example of how it is done in weather forecasting nowadays. They also use these spaghetti plots. And this is the link to the earth.nullschool.net for satellite-derived live winds and live currents. Let's have a quick look at that. Okay.